Introductions to Functions by Mathanit. Hold on. Okay. What is a function? Now, think of a function as a program you are coding. Fx is like the input of the function, or like the code that you have written for a program, and y is the output, or the game window, or the result of the code you've written. A function, the formula for solving a function we can use is fx equal to y, or y is equal to fx. A special type of function. A function is a special type of relation where every input has a unique output. For example, if fx was equal to 1 and fx was equal to 2, both of them would have a different output. A function is also a correspondence between two sets, the domain and the range. Examples of functions. The linear function. Oh, hold on. There's the linear function, which is mx plus b for their formula. The square root function, the square root of x. The absolute function, fx, is equivalent to the absolute value of x. And the quadratic function, ax squared and plus bx plus c. Or if this is the graph of the function, this is known as the parabola. Application for functions in real life. In real life, there are many things that a function can be used for, and these are just some examples. So, you use functions for machine learning, for example, data collection. For example, by determining the peak of a set of a set of people's height in internet usage or whatever. Aerodynamics, you can calculate like the aerodynamics of something falling. Mapping MRI scan data, which is basically like graphing your blood levels and like blah blah blah. Data collection and face recognition. The function and the relation. Now, a function is a type of relation. I've already mentioned that. A function will always be a relation, but a relation may not always be a function. The difference between a relation and a function. Now, as I said, a relation can be any kind of relationship between number sets, but functions are a special kind of relationship where there is only one y value for one x value. None of the values of a function will repeat. So if you look at my beautiful, beautiful chart below that I totally didn't draw in MS Paint, none of these x values repeat so this line is a valid function. The vertical line test. So you can figure out if a relation qualifies as a function by doing something called the vertical line test. You can draw one or two vertical lines on the graph, and if the two lines touch 2 points of the it is not a function. The vertical line proves whether any of the x values repeat. So, for example, this one is a function because these two lines drawn doesn't intersect again. But if you see this, the lines drawn, they repeat on this point, these 2 points, and these 2 points. Expressing a function. Now there are many ways to express your function. You can either express it verbally through your mouth. You can express it through an equation and then solve for it. You can express it numerically. You can express it using the coordinate plane, or you can express it using an input-output chart. The coordinate plane. Most of the time you use the coordinate for graphing functions, and the coordinate is a flat surface formed by the intersection of this line and this line. The horizontal line is the x-axis and the vertical line is the y-axis. The x and y-axis meet each other in the center known as the origin, however you want to say it. Now, the 4 quadrants. Each quarter of the coordinate plane is a quadrant. The first, now when you are graphing a function, you have to follow these rules. So for your first quadrant, which is this one, all values of x and y have to be positive, which means they always have to be greater than 0. The second quadrant, which is this one, all the x values have to be negative and all y values are positive. And the third quadrant, which is this one, both values x and y are all negative, And for quadrant number 4, the values of x are positive and y values are negative. The ordered pair. Normally, two numbers for which the order which they are given is important. And the ordered pair normally refers to a two-number set used to locate a point in a coordinate plane. When an ordered pair refers to the location of a point in the coordinate plane, they are called the coordinates of the point. It's kind of logical. Now, a tip to remember is that if the x-coordinate is positive, you move right from the origin. If the x-coordinate is negative, you move left from the origin. It's kind of like a number line. Like 0 is home base. If the number is negative, you'll keep going left. If the number is positive, you go upwards, like 1, 2, 3, and -1, -2, and -3, and so on and so on. Now, if the x-coordinate of the origin is 0, and the y-coordinate of the origin is also 0, then the ordered pair of the origin is 0 and 0. So your point just never moves; it stays on the origin. Review. So to prove whether these relationships are functions, you simply just draw two lines, 1, 2. The two lines don't repeat on 2 points on the graph twice, so this is a function. Now this one is not a function. This is a function. This one is not a function because this on each vertical line there are 2 points that repeat. Hold on. 1, 2, 3, and 4. So this is not a function. Okay. Solving simple equations for functions. Now, a very effective way and simple way you can use to organize your work for solving for functions is the input-output chart as shown below with examples. For example, this is the equation or the function or the rule or whatever you want to call it. Is y is equivalent to x, the absolute value of x multiplied by 3 and then plus 4. So 1, if you just plug this in, it's the absolute value of 1 times 3 plus 4, which is 3. Absolute 1 times 3 is 3. 3 plus 4 is 7. So the output is 7. So the coordinate points are going to be 1 and 7. Same for this one. It's the same thing. Absolute value of 2 times 3 plus 4. Y equals to 2 times 3 is 6. 6 plus 4 is 10. So the output is y. And then the coordinate points would be 2 and 10. And then the third one, for example, the absolute value of 3 times 3 plus 4. 3 times 3 is 9. 9 plus 4 is 13. The coordinate points on your graph would be 3 and 13. Hold on. Okay, the end.